Good morning, everyone. Uh, in today's video lecture, we're going to discuss about the computer design. The topic is issues in the code generation. Myself, Sharmila, working as an assistant professor in R.M.D. Engineering College in CS department. We're going to discuss about the issues in the code generation. First, we know what is the code generation phase. It's the final phase of your compiler. So there are seven different phases. That final code after code optimization, after the intermediate code generation, code optimization, final phase is code generation. In the code generation, what are the different problems, issues occurring in that we're going to discuss here. So here, the final phase in the compiler model is that code generator. You know that it takes input in say, intermediate representation of source program and produces the output of an equivalent target program, that is a mission level language program. The code generation technique represented presented below used to whether we are optimized phase or whether we have generated a code or not. We'll discuss in this intermediate code. First, the source program, that is a front end. After that semantic and syntactic phase, we are going for intermediate code. After the intermediate code generator, we are giving a code optimizer. The optimized code is given to the code generator. Finally, the code generated code is a target program, that is your mission level language program. In that mission level language program, while converting it, what are the different issues we are occurring there, and we're going to discuss the issues in the design of code generation is input code generator, target program, memory management, and instruction collection, register allocation, evolution order. Input to the code generator consists of the intermediate representation of source program produced by frontend together with the information in the symbol table to determine the runtime address of the data object denoted by the name in the intermediate representation. So in that input code generation, what we are doing is we are generating a source program to target program. So in the intermediate representation, we have linear representation, we have three address. Linear is called as postfix notation, three address called as quadruple, and virtual machine representation is called a stack machine. Graphical representation is called a DAG or syntax tree. Prior to a code generation, the front end must be scanned, parsed, translated into an intermediate code with the necessary type checking. Therefore, the code is assumed to be error free. That is the first phase of your compiler, that is input to be code generator. Second one is target program. The target program is nothing but your machine code program. There are different types of machine code programs are available. They are absolute machine language, relocatable machine language, assembly language. Absolute language is nothing but a fixed memory with a executable, immediately executable file. Relocatable machine language is nothing but is a subprogram to be compiled separately. Assembly language is the code generation is made easier. So these are the three different code generation output may be occur. Third one is memory management. In the memory management, the program are mapped to the address of the data objects in the runtime of the memory in the front end of the code and code generator. It makes a use of a symbol table. That the symbol table have the three address name to refer the symbol table entry for the name. Label in the three address statement have to be converted to address instruction. Example is go to I, go to jump, like that the instruction will be, whether it's quadruple means it will be having three address, triple means it will be having three, quadruple means four address, like that. Next one is instruction selection. In the instruction selection, the target mission should be completed and uniform. Speed, mission idioms, like efficient target program is considered. Generate code determine the speed and size, like that we'll discuss in this instruction selection. Register allocation, whether the register is allocated properly or not for the use of that register allocation. Register assignment, certain mission requires even odd register pair for some operation result. For example, d x comma y, x is to dividend of an even register and odd register for y. Even register holds the remainder, odd register holds the quotient. This is an example for how the register is allocated. Evolution order, in which particular order the evolution is performed. Efficiency of the target code and computation order required for few register to hold the intermediate result other than the others. So the next topic is about design of a simple code generator. In that simple code generator, how we will generate a code, how we will use a register. For example, they have an example x equal to y plus z. How the code is generated in the machine code is move x comma r. The x value is moved to r naught register. Now the R naught contain the x value. Add y comma R naught. What is the R naught is x. So y plus x we are adding and we are storing in the R naught. The R naught contains the x value. So the register address description is about describing where the track is, where the register is, where the location is, where the current value is. So the code generation algorithm, we have some points for generating a code generation algorithm. For assignment operation, how they are assigning code generation, how the register is allocated, how the address description is given. For example, t equal to a minus b. So how they are moving is move a comma r naught contains a value, subtract that a minus b. So b minus what is r naught is a. So r naught contains the t value. The t value is final output. So t is in the r naught address description. So generating code of index register. How indexing register b of I. How we can move b of I to r naught. B of ri comma r. So b comma a of ri. Like that you can move that. And then this is for example for pointer asterisk p asterisk rp comma a. So the a value contain the pointer of that p. So like that we have a different notation for the representation of target program. This is a direct acyclic graph. So here what for example is t naught a plus b. Directed acyclic graph is nothing but a structure of basic block. Helps to see how the flow value flowing among the basic block. For this purpose of DAG is to optimization. What optimization we are doing is no need to write again and again in the flow diagram already used variables. How to reduce the used variable into a short, precise and directed acyclic graph is given example. T naught is a plus b. So we in the a plus b we are storing in t naught. So we are adding t naught and t1 is again it's the value of t naught plus c. So t naught plus c. Again, D is T naught plus T1. No need to again draw T naught T1's one circle. Directly you can connect from T naught to T1 to D. So that is a type of drawing is called as direct acyclic graph. Next one is target mission. Target mission computer is a byte addressable. It have a 4 byte for a word. General purpose is R0, R1, R2 like that. We can use a register. It is having a two address instruction. One is for operation source, another one is for destination. They are given example how to calculate a cost. For example, if it is address means cost is one, register means no cost, and pointer means one cost, and indirect index means one cost. Like that, we have a value for cost calculation. They have calculated one example: move b comma r naught. The value of b is one, r naught is 0, move is 1. So move is 1, b is 1, r naught is 0. So total cost of that particular line is 2. Add is 1, c is 1, r naught register no value, so 0. 1 plus 1 plus 0 is 2. Again move is 1, r naught is 0 plus a is 1. So 1 plus 0 plus 1 is 2. Total cost of this particular line of code is 6. So total cost for the given is 6. Like that they have calculated for pointer, move is 1, r pointer is 1. So register no value 0. So 1 plus 1, 2. Move was 1, register value is 1. So 1 plus 1 plus 0 is 2. So like that totally 4. The cost of the program is 4. So today's video we have discussed what are the things is a direct acyclic graph, how to draw it and how to generate a simple code generator, design a simple code generator. And one more example what is given is issues in the code generation. What are the 6 different issues we have discussed. Finally we computed the calculation of how to calculate the cost of the target machine code. Now the final phase of compiler is target code, that is your code generation. In the code generated, what are the issues, how to calculate the cost of each code we have discussed. So I hope you understand this session very well with one good example how to write a code and how to compute a cost for each value of that code. Okay, thank you. We'll see in the next video.